Thanks. Well, now's as good a time as any, Mr. Miller. Take her down to periscope depth.
Yes, sir. Clear the bridge. Dive.
Stand right.
Greetings, everybody. I hope the audio's fine. I'd like to thank everyone who's joining me this afternoon. I hope you all have had a blessed Christmas. Welcome to the Evidence and Reasons YouTube channel, video channel, where we explore evidence and reasons for the Christian faith. We explore evidence and reasons that God has hidden away for us to discover. If the Christian faith were as obvious to our senses as the air we breathe, we probably wouldn't be having these discussions at all. But the Lord hides away things so that we might have the opportunity to demonstrate to Him and to the world our determination to find the things that He has hidden away for us to discover. It says in Proverbs 25:2, "It is the glory of God to conceal a thing. It is the glory of kings to search a thing out." And we here at Evidence and Reasons are doing just that, the glory of kings, to search things out that God has hidden away. I'd like to thank everyone that joined us yesterday evening on Christmas. We had a show for the shut-ins. I'm pretty much homebound because I'm taking care of my 94-year-old mother who nearly passed away in June of 2018. She was sent home to die, and lots of people prayed for her, and she recovered. But I want to, again, I'd like to say before everyone here that I thank God that I had another Christmas with Mom yesterday. Honestly, this summer I was concerned she wouldn't make it this long. So she's still with me. I'd like to thank everyone who's joined us, who's been a part of this channel, who's prayed for me and my family. Now, some interesting, maybe some news bites. I've been contacted that Modern Day Debate wants me to debate more. James Coons had some very kind words to say about my performances in debate, and he would like me there more to represent the Christian side. So I'm very honored to do that. Possibly in January, we'll see if if I have an opportunity to debate some big names. So I'm not really much into debate. And the reason why is I'm not much into short debates. If someone wants to have a year-long debate, yeah. Short debates, people can dodge. They can state things, just throw you off balance with non-facts, and you don't have a chance to fact check. But the sort of debate that I'm interested in is one that can take place and happen over the course of a year or so. I've actually been in some debates that have lasted, discussions that have lasted years, and I'm pleased to say that the outcome was favorable to my views, to the views of creationism. So, just some loose ends from last night. I shared the testimony of Dr. Richard Lumsden. He went home to be with the Lord some years ago, but he was instrumental to me, to me regaining my faith when I nearly left the faith 20 years ago. Now, who is Richard Lumsden? Well, if the name Mark Armitage means anything to you all, Mark Armitage was a student of Richard Lumsden. So Mark Armitage got a very nice settlement, well-deserved because of religious persecution, when he argued that the fossils he found were had indications of being young. Now, whether those specific fossils, some have raised questions about whether they're actually dinosaur fossils. At this point, it's moot, because people like Mary Schweitzer have independently found the same thing. So the evolutionary community was pretty mad and just wanted to get Armitage fired for just showing pictures and telling the truth. So things have moved forward for the young earth creationist cause. Now, also regarding Richard Lumsden, for those of you who heard the testimony on Christmas Day that I replayed, I was very skeptical. At the time in 2002 timeframe, I was despairing, and I said, Lord, this story just seems too good to be true, too good to be true. And there I was working at the MITRE think tank. MITRE stands for Massachusetts Institute of Technology, Research and Engineering, in Tyson's Corner, Virginia. The joke is that MITRE actually stands for MIT's Rejected Engineers. And I was working there, and I was despairing. My father was terminally ill, and he passed away in 2003. And I was just going through a lot at that point in my life. And I said, Lord, I'd like to believe that Richard Lumsden is who he says he is. And this just seems so fantastic. And I said, well, let me do a little fact checking. It said that Richard, in creationist literature, it said Richard Lumsden had won the Baldwin Award. And I said, well, this is easy to fact check. I can Google that. And in that list was a list of all the people that had won the Baldwin Award in parasitology. It's the most prestigious award in that field that can be awarded. And there it was, Richard Lumsden. But immediately before or after him, it said Franklin Sagandaris Bernal. And it struck me. I said, Franklin Sagandaris Bernal. I said, that's a remarkable coincidence, because there's someone who has a very similar sounding name that I work with. His name was Frank Sagandaris. And so I said, okay, this is a real shot in the dark. But let me ask him. And so I asked my coworker, I said, are you any relation to this Franklin Sagandaris Bernal who won the Baldwin Award? And he said, yes, that's my dad. And I mean, it almost brings tears to my eyes, because I was saying, Lord, please give me a shred of evidence that this story by Richard Lumsden is true. If even one or two scientists break rank, scientist of high caliber like that and say Darwinian evolution is false, I have a glimmer of hope that the Christian faith is true. Because if life is a miracle, there has to be a miracle maker. And there it was. And I asked Frank Saganderas asked me, he said, that's kind of amazing. That's a really small community, these parasitologists. And I said, well, I was looking up Richard Lumsden, and I saw your dad's name. And he said, well, yeah, Richard Lumsden, Dick, he used to, Dad and Dr. Lumsden used to hang out. We used to visit each other's houses. And I was just struck. I said, the Lord knew I needed to hear that. That was some of the spark I needed to keep me going and to keep searching for evidence and reasons for the Christian faith. And just this year, I was sharing the story with my private Bible group that kind of grew out of McLean Bible Church. And I was sharing that story, and one of the members of the group said, I know Frank Saganderas. He and his kids, his kids and mine used to be on the same swim team or some activity, so they knew each other. And I was just struck. I said, yeah, God's reminding me that he's there. He's dropping these subtle hints. So I failed to mention it yesterday, and I said, I'm going to say something about it. And I realized, oh my, I totally forgot to mention this yesterday. So I'm saying it now, that when I heard Richard Lumsden's story, I said, this seemed too good to be true. And what are the odds that over 1,000 miles away, I'd be working in some place and there's someone there that knew Richard Lumsden personally? And for those of you who joined us late, I also wanted to mention last night, Richard Lumsden, one of his famous students in the creation evolution controversy was Mark Armitage, who won a settlement against the University of California system, I believe. If I get the university wrong, I'm sorry, because of religious discrimination, because he was reporting on the youth of fossils that he found. And that's getting under the skin of evolutionary biologists, and they're calling it religious, which is really funny, because the people that are showing more religious fervor, absent of any science, are the evolutionary biologists. It's the creationists that are having greater respect for the facts now. Maybe they did have, and admittedly they had a bad reputation for not, and possibly somewhat deserved, for disregarding facts, but that's changing now. It's flipped. As I deal with origin of life researchers and evolutionary biologists, it is them that are ignoring the facts and moving on faith despite the facts. So, Merry Christmas to everyone. This topic today will have two parts. One part that is a little bit humorous and very superficial, stuff you may have heard me cover. And then there's a part that's going to be really technical and it's going to put you to sleep. So let me just go ahead and greet everyone that I see in the chat. Greetings to Hate Love Nothing, Jeremy Martin, Lena Powell, and Brandon, and then others who've joined who are also not in the chat. And MP Reziv, God bless you. Merry Christmas to you all. So let me see if I could show an interesting headline here in the United States. This was in December 21st, 2005. Let me show my screen. And I'm learning how to do this a little better. Getting a little bit more acquainted with StreamYard. And there is the headline, December 21st, 2005. Here in the United States, there was a big trial in the Dover District of Pennsylvania, which is on the East Coast of the United States. And they were, the judge was trying to rule whether intelligent design can be taught in public schools. And the judge ruled intelligent design is not science. This was very demoralizing to the intelligent design community. And the argument went that the intelligent design was just creationism, just kind of redone so that we could sneak it in the public schools. But despite this ruling, intelligent design has moved forward. The reason I know that is I'm seeing more and more academics quietly, and then sometimes not so quietly, who are first rate, like Change Tan, like Rob Stadler, like Ryan Hayes, like Dr. James Carter, like Dr. John Sanford. I could name some more, and perhaps I shouldn't because I'll get them in trouble. But these are Harvard, MIT trained people. These are not like the creationists of yesterday that may not have been as credentialed as the ones in the present day, but there are more and more of them. And so even though we may have been losing the fight in the public schools, we've not been losing the fight on the evidence. We've not been losing the fight on the evidence. So people will say, well, the judge ruled intelligent design is not science. And I've often said, in the great scheme of things, if there's an intelligent designer of life, does it really matter whether we call intelligent design science or not? Does it really matter what a judge has to say? Isn't it more important that there's a creator, a designer? Now, the Christians, there are some people that believe the intelligent designer of life is aliens. And it's a little hard to say this, but God bless them too. They're part of the ID community. They have moved the argument forward. They have contributed to the intelligent design argument. But the creationists who make, by and large, the large bulk of the intelligent design community, they believe the intelligent designer is the Christian God. And I'm perfectly fine saying that. So today's topic is, goodness, have I forgotten the title already? What was today's topic? It was the law of large numbers and intelligent design, Shannon, entropy, and statistical mechanics. So that's kind of an overview, and I know that's kind of intimidating. Oh, by the way, we have a new member, Clay Corbin. He said, "Love you, Sal. However, ID isn't science. It does matter if we call it science." Okay, this is I sometimes break with my brethren. I actually would agree. Intelligent design falls outside of science. So I'll agree in part. Because science deals with repeatable experiments. We can't tell an intelligent agent, hey, participate in our experiments. If he doesn't want to participate in our experiments and show himself up, we're not going to be able to repeat the experiment. If we tell God to show up at our whim, when we want, however many times he wants, and he does it, at that point, we're God. It just doesn't work that way. But what I will say, abiogenesis and evolutionary theory are not science either. They're just metaphysical beliefs pretending to be science. And that is, they don't like me saying that. And this coming year, I'm going to be trying to argue. I'm going to try to argue that this is not the sort of thing that can be decided in a 1-hour debate. So we are moving forward very methodically and systematically. So I mentioned the Dover trial. That was a big deal. The American Civil Liberties Union and lots of legal entities and then advocacy groups on both sides were fighting to win this. And one evolutionary biologist by the name of Nicholas Matsky, we call him Nick Matsky, he became famous because he worked for the National Center for Science Education, the NCSE, which we affectionately call the National Center for Selling Evolution, NCSE. And Nick and I had many exchanges over the internet in text. We never debated live. So here's this guy in 2005, and he's just basking in the glow of this legal victory. in Dover, Pennsylvania, what they call the big intelligent design case, as if Judge Jones, a human judge, can rule for all the rest of the universe that Darwinian evolution was true and intelligent design wasn't. How silly is that? Okay. How silly is that? But anyway, I'm going to share my screen here, and this relates to the law of large numbers. And at the time, Nick, I have to say, the way the intelligent design proponents were framing their arguments was not too good. And I came and I went after Nick Matzke with this, the law of large numbers. So this screen here is from the Uncommon Descent website, and I'm going to put a link to it here. I put it in the chat, and you can watch this. This is a very interesting exchange. Barry Arrington, who ran this Uncommon Descent website here, I asked him, I said, why don't you ask Nick Matzke, ask him this question. Barry didn't use the exact words I would have preferred, but he asked Nick Matzke, this hero of the evolutionary biology community, he asked him on my behalf, he said, quote unquote, Nick, if you came across a table on which 500, if you came across a table on which was set 500 coins, no tossing involved, and all 500 coins displayed the head side of the coin, would you reject chance as a hypothesis to explain this particular configuration of coins on the table? Really, a simpler way of saying this, and I would have preferred Barry use my specific choice of words. I said, if you came across a table with 500 fair coins and it was all heads, would you reject chance as an explanation for that pattern? Okay, so this is the guy that was helping the expert witnesses in the Dover trial. A simple, he could have said, yes, I would reject chance as an explanation. I would reject chance. He could have said, well, yeah, I would reject chance. I think a human being had flipped it. He punted. He couldn't make a simple yes or no answer. And so there were, for 151 comments, we were just hammering him over this. And I said, Nick, why is this? We're not even talking about life. Why is this making you feel so uncomfortable? I mean, because at the time, the ID proponents had a hard time saying, how can we establish that something is improbable? Because the probability arguments were a little bit flimsy, in my opinion. But this is the first time that I came forward and said, let's use the law of large numbers. Let's see how do you like them apples, to use an American saying. How do you like them apples? And so you could read through here, and we were just laughing at Nick. So someone weighed in. Someone said chance is meaninglessly vague as a hypothesis is design. And then Nick would weigh in what Mark said. And then he said another hypothesis is all the coins have heads on both sides. And he knew I was talking about fair coins. And he just kept equivocating. I said, Nick, I challenged him. I said, let me see if I said this. I said something to the effect, you can look this up. I said, if you were Nick was planning to be a professor at school. And I said, Nick, would you feel comfortable kind of floundering on this question before your students? What would you say? You understand statistics. I'd be embarrassed. I'd be embarrassed to be kind of doing all the dodgeball that you're doing. I mean, I didn't use that word now. I've learned a new word, dodgeball. So I said, Nick, what, you ought to be embarrassed. Why is it you're so uncomfortable with a simple question? All I was asking was, if you saw a table full of fair coins and they're all heads, would you reject chance as an explanation? There's a reason he may have had a feeling, he may have had a intuition that I was really going somewhere with this, that I was planning to go somewhere with this. And let me see if I could find, yes. I'm going to bring up my, I'm going to bring up, let me share my screen again. A slideshow. So I said the law of large numbers. So just for what it's worth, the reason that the coins, we would reject chance as an explanation for that configuration is that it violates the law of large numbers, and we'll cover that a little bit. But let me see if I could find, this relates to the origin of life. So here's an example. This is talking about homochirality, but it applies to other things like consistent linkage. There's not really there may be quasi plausible but not very good explanations for homochirality, but it faces the problem of the law of large numbers. So just even the first round of the origin of life, it already faces a big hurdle with the law of large numbers, just with homochirality. But then the next step where the law of large numbers comes into play is what they call homolinkage or consistent linkage. And this was the diagram that Change Tan built. I'm getting way ahead of myself. So let me pause a little bit. I see that the group we have here, I recognize most of the names, and Seeking the Narrow Way, I wanted to thank you for your advice on thumbnails, and I will try to be more careful about these things, especially if I have a big debate. I want to use materials that are on the up and up and won't be contested, because I look forward to that debate being circulated. I've been informed James Coons wants me to debate bigger and bigger names than T-Jump. No disrespect to you, T-Jump. That being said, since I recognize most of the names here, I would be very grateful if someone would like to would join me in the stream. So any of you that I've recognized are welcome to join, because it will help. I'm going to throw some terms out there, and I kind of need to get a feel if I'm communicating it adequately. So if someone would like to join, I would be deeply appreciative. You would help this channel a lot. So even if you're maybe a little shy or whatever, you don't have to show your face on camera, but I would be personally appreciative if you would join the stream. So let's talk about the law of large numbers. Let me try to bring this up again. We'll talk about the law of large numbers, and this relates to statistical mechanics. So I gave you the easy part. And we're going to get progressively nerdy through the course of this afternoon's talk. I have no idea how long this talk is going to go. We've already gone half an hour, but I gave you the easy part. Just intuitively, we know that if we throw all these coins on a table, I mean, if we've encountered a table with all heads, and these are fair coins, that it isn't a random process. You know, I was invited by some parents in my church to teach their kids creationism, and there's this little 6-year-old kid, and I said, how am I going to teach this to kids? I mean, he's only 6 years old. But you know what? I gave a little exercise. I said, Eli, just go out of the room. And I had like 20 coins with me, and I flipped them. I configured them all heads and left them on the table. And I said, come back in. And he said, oh, you touched those coins. He understood that I had done something. And I said, you know, that's really amazing. This 6-year-old kid could recognize that this was design. A PhD evolutionary biologist couldn't bring himself to admit design on something as trivial as that. Oh boy, out of the mouth of babes. Praise God. So we're going to cover a little bit of the formality. So we know this intuitively, but now I'm going to drag you through the formality so that we can make this argument more rigorous, because Icarus, and this is really true. I mean, these guys, these guys defending evolutionary theory and abiogenesis theory will not give an inch. They will not give an inch. There was a 1.5 year debate on this topic in text between two blogs. I'm just like, guys, this is ridiculous. This is ridiculous. You wouldn't be teaching this in school, but they were just fighting me, because I would just take stuff out of the textbook, put it on there. And the first thing they'd just reflectively say, Sal's dishonest, or he's stupid, he's ignorant. And I was just laughing. I said, this is textbook stuff. And it's just funny to see all the things they would do to save face. So now let me proceed a little bit with the formality now. It's going to get a little bit more technical. Anyone who wants to join not wants, but anyone willing to help me, please join. So now I'm pleading. So let me now share my screen. So the law of large numbers, I'll say this, that the way we're able to detect design between humans. Okay, let's just start with something simple. How do we detect human designs that are very convincing for designs like we've never seen before? And I had an exercise. Let me stop sharing my screen for just a second. I had an exercise where I had an extracurricular class at James Madison University. This was extracurricular. I wasn't a professor there, but we just organized some things, advertised it through the Christian groups. I said, would you like to learn about intelligent design and creation science? By the way, I'll have another show on the distinction. There is a distinction. Why don't I just cover it briefly? Intelligent design says there are aspects of the world that are designed. Informally speaking, creation science or creationism argues the world is intelligently designed. It's also intelligently cursed, and there's also a chronology. It's just that distinction. So we could say intelligent design within the context of creationism can be viewed as a subdiscipline within creationism, if we're starting out as creationists to begin with. Now, there are people that are intelligent design advocates that are not creationists, and I want to acknowledge that. So let's see. Lena's kind of goading Brandon, said, Sal will explain, join the stream, please. Okay, so I'm inviting people now actively to join the stream because it's a little hard to do this by monologue because I'm guessing, I have to guess how well I'm communicating. So when I get feedback. So if you don't want to join the stream, and I totally respect that, try to say something in the chat. I'll try to monitor it. So I would sincerely ask, let's try to keep the chat focused on the technical questions. I know there are arguments about whether Christmas is appropriate to be celebrated by Christians. I'm just going to ask, guys, can you take it somewhere else today? And oh my goodness. Merry Christmas, Lena.
Merry Christmas, Sal. Can you hear me?
Yes. Okay, can everyone hear Lena? All right. Thank you. Merry Christmas. It's been a while. Thank you for bailing me out. So anyway, I'd like to thank everyone for joining. So we're going to get to the law of large numbers. So before I move on, were there any questions or comments about Nick Matzke and those coins on the table?
I don't know if your audience knows Nick Matzke.
Okay. Nick Matzke was involved in this famous Dover trial. In the United States, it was a big deal because there was a push by some people who are actually not part of the intelligent design community to try to force intelligent design into the public schools. And this is just a terrible situation because intelligent design advocates didn't want intelligent design taught in the Dover school system by the school board the way the school board was trying to teach it, they felt that it was going to be a disgrace to the intelligent design community, and it ended up being that way. So anyway, this was a big trial, very, very, court cases in the United States determine a lot of public policy. And this court case was going to determine whether evolution could be challenged in the public schools. So Nick Matzke was part of the legal team advocating Darwinian evolution, and he was the evolutionary biologist, the resident evolutionary biologist, providing stacks of material to try to discredit Michael Behe and Scott Minnick and William Dembski. And when the judge ruled against intelligent design being science, Nick Matzke kind of became a minor celebrity. And so he was like he was a nationally renowned evolutionary biologist, nationally renowned. And so he and I were always sparring on the internet before the trial. And so this is really funny. We were just kind of like these people, random internet people. At the time when we met, he wasn't even a PhD. We were just like a lot of people here on the internet, just arguing with each other. So it was just really strange. He ends up being in the national headlines because of the Dover trial. I ended up being on the cover of Nature, and we're just two random guys. And then, so we continued sparring after all this. And so I said, okay, I said, yeah, I want to spar with a giant here, a celebrity evolutionary biologist. And so I was just going to ask him that simple question. And he punted. A 6-year-old kid could answer it better than he did. And someone said, yeah, Nick probably knew the right answer, but he had a lot to lose by being truthful. So now I was talking about a extracurricular course that I had run at James Madison University. And we would have, I give out to the students two small boxes, two small little school boxes. And each of the boxes would have coins and dice. And I would instruct the students, I said, okay, in one box, you just shake it randomly. In the other box, arrange the coins and dice in such a way that it's going to be really obvious that you designed the arrangement. I want you to put it together in a way that there's just not going to be any doubt. I'm going to step out of the room with my assistant and give you just, maybe about 5 minutes. And we'll come in and we'll see if we can identify which things are designed or which things are the result of a random process like shaking. And we went and inspected all the boxes, and we never got the answer wrong. It was very obvious what was designed and not designed. And I said, well, this is really kind of strange. How can we make this a little bit more rigorous mathematically? And more importantly, how can we extend our intuitions rigorously to the molecular level and argue the same for life? It's not as easy as you think. Because there are a lot of things that we know intuitively, but to actually make it rigorous mathematically is difficult. So everything I just shared, I kind of gave at the intuitive level. Now we're going to get down into the rigorous part, because this is how we will argue rigorously against the origin of life. So Lena, feel free to interrupt me anytime if there are any questions. So what is...
Are you going to use the term expected value?
Oh, yes.
Which is actually what we intuitively expect or intuitively conclude.
Yes.
Or how would you define it? Okay. Mm-hmm.
Yes. And this is where it gets kind of nasty. Now, I want to just tell the audience, Sal, why are you being so rigorous about this? It's because when you're not, the other side will just make up stuff, put words in your mouth. When we go through it rigorously like this, we're kind of staking a claim on the ground in cyberspace and saying, all right, we're making our stand here. This is your chance to refute an actual rigorous argument. And it's kind of nice to know. I don't get a lot of videos made about me in particular that are saying I'm wrong. I try to do things just straight out of textbook science and math and physics. And I will cover expected values. So to get there, so the just briefly relating it to the coins on the table, all heads, it's a violation of expected value. The law of large numbers,
Correct.
right?
Yeah.
Anytime you construct a configuration that's a violation of expected value, or more generally, expected outcomes, a substantial violation of expected outcomes, that's an indication of design. Now, we can't prove absolutely it indicates design, but we can say it's improbable in the formal sense, and then it has to be dealt with. The reason that's important, if abiogenesis people says it happened naturally, it's like, okay, we can challenge what that means, because if what they're saying is analogous to a tornado going through a junkyard and assembling a 747, we will say that's a violation of expected outcomes. And you can kind of sense it already with the homochirality, and then even more importantly, the homo linkage argument that physical chemist Change Tan put forward. When there are violations of the law of large numbers there, which is one of the most important statistical laws, we have to begin to question. I said, do we have any right to say this is natural? How far away from expected value must it get before you begin thinking this is a miracle? And honestly, when expected outcomes, when Eugene Koonin starts to invoke multiple universes, and then concurrently physicists are arguing for multiple universes to solve the fine-tuning problem, these are all things that are invoked to circumvent the problem that there's been a violation of expected outcome. And when I say expected outcome, that's kind of that's more general than expected value. Expected value is a very narrow thing, and they're kind of expected outcomes that are, it can't be exactly described by the law of large numbers and expected values. So we'll get a little bit more into this. Lena, did you have something you wanted to say?
No, I just wonder if your audience knows, because I understand what you explain, and I know the law, because I know in general what the law of large numbers is, but I wonder if your audience is not confused.
Well, let me just briefly look at the chat. All right, if they are confused, this is why I'm inviting some of you to join the chat, and I hope I can explain it. So, good point. And one reason I'm trying to go through this is they can actually, I'm going to derive it from first principles, and it's going to get technical. So, for those of you who may be confused, go back to that 6-year-old intuition. That 6-year-old kid, he saw the table with 20 coins all heads. He knew something was up. That intuition is correct. The hard part is making this rigorous. Now, I had a math professor who said, well, it's important to make things rigorous, but don't make it rigor mortis. All right. So I'll try not to make it any more technical than needs to be. The only reason I'm applying rigor is so that we can apply it to things like the origin of life question, and also like things like eukaryotic evolution and protein evolution. So here's an idea. I said configurations of objects that makes possible but simultaneously improbable. So if you think about the coins, it is certainly possible that these coins can be all heads. Physics makes that possible. But it also makes it improbable that it's going to be all heads through a random process. That's all that I meant. So to show design, what a designer who wants to show that he designed something he's going to choose objects that have a lot of possibilities, that have, are like the coins that can be flipped heads or tails. If the designer chose two-headed coins and he wanted to show some design in his configuration, it's not going to be very convincing, because if it's a two-headed coin, that for some of these some of these toys that are just given for amusement, the coin will be heads on both sides. It's not as compelling if the coins are two-headed. But if they are fair coins with heads and tails, then a designer wanting to communicate his ability, something as simple as just making it all heads, he can do that. So the first thing is to choose materials that will help you communicate design. And so you can kind of see where I'm headed with this. We creationists believe that God had chosen certain kinds of materials like amino acids, DNAs, RNAs, lipids, and carbohydrates that will communicate design if it's arranged in a certain way, because these allow the application of the law of large numbers. So let me go back and I will show the screen.
And so, if
Yes.
it is actually called the law of large numbers because it implicates a very large number of trials, and the larger the number of trials, the closer we get to the expected
Value.
value. But you call the value outcome.
Okay, so thank you for pointing that out. We can call it, let me back up a little bit. It is the expected outcome that it's going to be an expected value. And I'll make the distinction. So
Okay.
why don't I just focus on expected values for now? Just so I don't confuse things, because I can see that I added some confusion terminology, and because I've been getting way ahead of myself. So let me quote this from Steve Benner's paper. The asphalt paradox: an enormous amount of empirical data have established as a rule that organic systems given energy and left to themselves devolve to give uselessly complex mixtures, asphalts, not literally asphalts, but figuratively speaking. Theory that enumerates small molecule space as well as structure theory and chemistry can be construed to regard this devolution a necessary consequence of theory. Okay, this is very technical language, but this is like saying if you take 500 coins that are fair, and let's say they started out on a table, they were all heads, that you just manually did that. If you start shaking those coins and flipping them, they're going to quote unquote devolve into almost being 50% heads. And I'll show the math some. But it's kind of you can extrapolate this to chemistry. And that is the problem they're trying to solve. And this is kind of how I picture it. This is from Indiana Jones, someone devolving. And people had said I've misquoted and Benner, and I'll say Benner believes in naturalistic origins, but then he writes papers like this. I said, well, you've given every reason we shouldn't, but then you still believe it. So he closes the paper by saying, thus, even if we solve the asphalt paradox, the water paradox, the information need paradox, and the single biopolymer paradox, we still must mitigate or set aside chemical theory that makes destruction, not biology, the natural outcome of our already magical chemical system. I mean, this was just a devastating paper. And I'm just like, okay, so you've listed all these reasons that origin of life should fail, and you still believe it. And I say, yeah, that's faith. That's faith, not science. This is Eugene Koonen's group at the NIH, and pictured there is also my professor. He was part of this group, but this is Eugene Koonen, and he's appealing to multi-universes to explain this violation of the law of large numbers and other things. Uri Miller. And I'm still not getting, okay, so we talked about, this was, we can go back after I cover the law of large numbers a little bit to change Tan and Rob Stadler's book. So we covered, okay, this is a fair coin representation of it. It has heads and tails, and it does relate to chemistry. And there are peer-reviewed papers that refer to the law of large numbers and the problems it causes. And I'm just citing that. So a great way to frame problems in the origin of life is to appeal to violations of the law of large numbers. So according to the law of large numbers, the average of the results obtained from a large number of trials should be close to the expected value and will tend to become closer to the expected value as more trials are performed. And I'm sorry for the technical language here. What I'll try to do is to show some of the intuitive ideas and try to relate it a little more to the technical language. So I'm going to show my screen here. And this may be surprising. You'll see the calculation for expected value in all sorts of ways, in all sorts of venues. For example, Shannon's information theory. This is actually a formula that describes expected value in terms of logarithms. It's Shannon's theorem, Shannon entropy. And so let me just go ahead and this one's here, Boltzmann's statistical mechanics, thermodynamics, the definition of entropy. It has expected value built into it. We don't have to go into the depths of the math here, but let me now try to show a little something with expected value. So I had some, let me put this up here. And we're going to start to learn new terms, because if we start talking about information theory, thermodynamics, and entropy and law of large numbers, it's helpful just to learn new terms. So strap yourselves in. This is class is in session now. All right. So if we had a one coin system that has heads or tails, we'll say there are two possible microstates, two possible macrostates. It'll be easier if I move to the two coin system. It'll make sense. So if we had two coins, there are four possible ways we could configure the coins. We could have both coins heads, or coin number one heads, coin number two tails, or coin number one tails, coin number two heads, or both coins tails. Any problem there? And anyone in the chat, if you don't understand, please. Flash Gordon says, technical jargon, do you have some crayons? Okay, so I use some coloring here. Lena, does that sort of make sense? There are four ways to configure two coins.
Yes, but I understand it fully, 100%. I only do worry about the audience.
Yes, and this is not easy stuff, because it's a new way of thinking of things. So Flash said, do you have some crayons? So I did. One way we can learn, and I really believe this, is if we colorize things. So there are four ways to configure the system of two coins, four possible ways. And each possible way is what we call a microstate. So you'll hear this term in thermodynamics a lot, microstate. So do you see that there are four microstates, just these four rows here? All right, now you could see this is 100% heads and 0% heads in the configuration. And then this is 50% heads and 50% heads. So there are three possible macro states. One of them is 100% heads, another is 50% heads, and another is 0% heads. So there are four possible microstates, three possible macro states. Let me move forward. You could, hopefully you can kind of see this. Just mull over it. And I'm trying to just show this kind of methodically. And I appreciate Flash's comment here. Do you have crayons? I think coloring helps. So let's look at if we have 3 coins, greetings, Matt. Thank you for joining us. Greetings, Matt. If we had 3 coins, we have 1, 2, 3, 4, 5, 6, 7, 8 possible ways we can configure the 3 coins. Let's call them microstates. So there are 8 microstates. Everyone okay with that? There are 8 microstates if we have 3 coins. Okay, this is statistical mechanics here. So if someone asks you, what did you do this afternoon? You can impress people and say, I studied statistical mechanics today. All right. So now this may seem trivial, but I'm trying to build the intuition to understand bigger things. And the law of large numbers will start to make sense as you ponder this. So this, you can mull over this for a day or more. I have to be able to think about the meaning of the terms. So we have 8 microstates, but then if we color things in terms of the percentage of heads, and we could see we have one situation where we have 100% heads, another situation where we have 66% heads. That is really 2/3, where you have 2 heads and 1 tail. And I mark those in the blue color here. So there are 3 microstates that have 66% heads. And then 3 microstates that have only 33% heads. And I mark those in the orange, the dark orange here. And then there is 1 microstate with 0% heads. Is everyone fine with that? Let me look. Okay, seeking the narrow way. Can you explain the microstates a bit more? I get the macrostates. Okay, thank you very much for that question. The microstates basically are the states that are possible of the system. They're only, if you think about it, let's just go to the 1 coin system. There are only 2 possible states of the system with 1 coin, heads or tails. But when we get to 2 coins, there are 4 possible states that we can arrange the coins. So if we, again, let's just say you had maybe a Sharpie, you could actually say, coin number 1 and coin number 2. You would be able to distinguish between coin number 1 and coin number 2. This only works for coins. In thermodynamics, that's a whole nother story, but this is a good educational way. So, you could that's why I'm laying it out here. You could see that there are only 4 ways that you can arrange this. There's no more, no less. Exactly 4 ways with 2 coins. When you get to 3 coins, you can arrange it this way. So I encourage you all, just as an exercise, one thing that really helped me is if you actually do this, not just in your mind, but just take some coins out, mark them, coin number 1, coin number 2, coin number 3, and just figure all the ways you can arrange them. You're only going to come up with 8 if you have 3 coins. And then if you have 4 coins, you get 16. So the number of ways you can configure it is obviously related to the number of coins in the system. So the number of microstates corresponds to the 2 raised to the number of coins. So 2 raised to, if we have 4 coins, we raise 2 to the 4th power. There's 16 possible microstates. So, all right. So seeking the narrow way says, I get the microstates now. Bravo. Okay. So you could see that this is kind of confusing because you have 16 microstates and you have 5 possible macrostates. So let me just cover this just to be thorough. We have, for 100% heads, that's 1 macrostate. And I designate that with this green color. 75% heads, so you could see like 3 are heads and 1 is tails. I designate that in the blue color. And you could see there are 1, 2, 3, 4 with that blue color. And then there are the number with 50% heads is you can see it by counting the number in the orange, the dark orange color. There you have it. There are 6 microstates with a macro state of 50%. And then let's look at the ones with just 25% heads. There's 1, 2, 3, 4. So that means there are 4 of them. And then there's one microstate that has no heads. Now let me see if I can show this. Hang on. Hang on. Any questions, Lena?
No, so do not worry about me. I will. I had further mathematics at the university. I want. At the moment, I'm trying to find something that the audience maybe would be confused about.
Okay. So, okay. All right. Just for the sake of those who want more, and I have to emphasize, if people really want to study intelligent design, this is not going to be easy. If one has the desire to be able to defend the arguments rigorously and well, I don't know that they're shortcuts. I mean, what I mean by well is you can get up and fight a university professor on this. You'll be competent to debate him, and he'll respect you. I hope he will. At least he'll know he's not dealing with someone who just had a shallow understanding of these things. So I want you to see this line here. It says 14641. 14641. Do you see that? Do you see how or I'm able to count the microstates here? You can either do it by counting, which is the painful way. I mean, you could do this for 4, 5, 6, 7 coins, and you can count the number of microstates that correspond to a macrostate. That's really painful to do it manually, but I did it manually so you could see it. And there is a formula that helps you do this faster, more efficiently, and it's called. It relates to Pascal's triangle, and you end up using combinatorics. Now, don't be worried about that, but I'm just pointing this out for those who want a little completeness where the theory comes from. All right. So don't expect to digest this all at once, but I want you to see something. Do you see, like, okay, so we have, okay, so you see the second row in Pascal's triangle, it says 1, 1. Let me show it to you here. See, 1, 1. And the next row is
1, 2, 1.
Yep. Now let's look at this here. Mm-hmm. So when we have the
with 3.
Yeah, let me. I had the wrong. Did I totally messed this up? Okay, with 2 coins, 1, 2, 1. So with 2 coins, you have 1, 2,
yes.
1. Mm-hmm. And let me see if I could do this side by side, so it's not so. Let me see if I can even get Pascal's triangle to come out. All right, this might be even better. See, 1, 2, 1, and you see 1, 2, 1 here. So let's go back. Pascal's triangle. So you have 1, 1 here, and then the next is going to be 1, 2, 1. 1, 2, 1. The next should be 1, 3, 3, 1. So let me verify that. Oh, let me. Apologies here, wrong screen. The next should be 1, 3, 3. Oh, there it is. I'm sorry. I'm having just a see 1, 3, 3, 1, and that corresponds to Pascal's triangle. 1, 3, 3, 1. See it? 1, 3, 3, 1. 1331, and you see 1331 there. The next should be 14641. And let me do that. All this to say that there's formulas to calculate this out. Because if we had to do this manually, you could see how much labor, this is labor intensive. This is just going to be miserable going through this. All right. So now we're building up to the law of large numbers, and we're going to refute something Icarus was saying. This was a 1.5 year long debate I had to try to refute, where they're saying, well, every situation's equal. We shouldn't be, we shouldn't be surprised when we see something all heads, which is just a ridiculous argument, but they are putting that argument out there. So you could see that this is a painful process if we even just getting up to 4 coins. How about 500 coins? If we get it up to 500 coins, don't even try it. Don't even try to count it out, all right? It's practically impossible to list all microstates if you have 500 coins. How many microstates do you think we might have if we had 500 coins? Okay, so for 1 coin, it's 2 microstates. For 2 coins, it's 4 microstates. For 3 coins, it's 8 microstates. For 4 coins, it's 16 microstates. For 500 coins, the number of microstates is 3.273 times 10 to the 150th power. You're not going to be able to list it out. You're not going to be able to list it out. And if I could revisit this, you could see that I could assign the number of microstates that correspond to a particular macro state. And there's also a percentage of probability it will, that we could find that particular macro state. Okay, so I know this is getting tedious. It was hard for me, and I don't expect everyone to get it in just one pass. This is not easy. It's not that you can't comprehend it. It's just such a different way of thinking about things. That's why mathematicians are just very different people. They look at things in a very different way. And if you bash your head around it long enough, you'll get it. Just kind of keep hammering away at your head, and it'll make sense. So now the computer will blow up if I listed all 500 macro states and try to assign the probability. But just suffice to say, if we had 500 coins and we're just counting up we have a macro state where 250 of the coins are heads. And there's a 3.5% chance 5.7% chance that it's going to be 250 coins heads, or 50% heads. Now, we might be 249 coins heads, all the way down to say 228 coins heads. But basically, this is all still about 50%, give or take 4.4%. So if we say it's very likely, there's a 95% chance, and I'm not working out, if you want me to work out the math, I can. But if we say that the chances of it being 50% heads, give or take 4.4%, that'll cover 95.5% of the time, 59% of the time, it's going to be that. It's very, very rare that it's going to be increasingly rare that it's going to be like something less than 228 coins heads or more than 272. So the point is, like that kid example, when you get up to 500 coins, and this is what Nick Matsky couldn't comprehend. Well, he could comprehend it. He just didn't want to deal with the truth. It's astronomically remote. The chances of it happening are 1 out of 3.273 times 10 to 150th power. That's what they call the universal probability bound. It's just remote. Forget it. It's just, practically speaking, it's not going to happen. And what Icarus was saying, he was saying, well, every microstate is equally likely, which is true, but not every macrostate is equally likely. That was the point. And I said that motivated me to have this presentation today. So when we say that, what does the law of large numbers say? Well, if we have a fair coin that has a 50% chance of being heads and 50% chance of being tails, if we have a system of 500 of them, the likelihood that it's going to be heads, 50% heads, that's the most likely outcome, give or take a little bit. Now, I know I didn't phrase that very articulately, but in general, it's going to be approximately, we would expect, the expected value is 50%, give or take. Deviations from that would be rejected as, if we saw deviations of that, then we would reject chance as an explanation for the configuration. And I just went through the formalities. The reason I went through the formalities is the atheists for a year and a half, they said, oh, it's, if we saw 100% heads, that's not particularly astonishing. I'm just like, guys, how can you say that with a straight face? You don't want to, we're only talking about coins, and, you know, we're not even talking about origin of life and homochirality and homo linkage. You can't even with a straight, you know, how can you say that with a straight face that you think it's that likely? You know, it's not particularly astonishing that you would find 500 fair coins on table, all heads. I just couldn't believe the denial. I said, we're not even talking origin of life. Why is that making you guys so uncomfortable? Is that because finally I'm starting to gain a little headway in making statistical arguments? Because, you know, it's just a small step to argue this at the molecular level, where we actually do. Thank God we're starting to see the law of large numbers in peer review literature, and it's confronting people. It's confronting people. They're using exactly that term and saying this is what has to be overcome. And it's sometimes they'll say, yeah, it's kind of hard to accept this because of the law of large numbers. So let me just read some comments here. There is one in astronomical number chance that a single organism arose by chance. Last I remember, it's a number greater than the atoms of the universe. Imagine picking one random atom out of all. Yes, we call that the universal probability bound. But at a personal level, at what point is someone going to wager their soul on such remote odds? Seriously, that there's no God, that there's no miracle maker. I said, okay, I'm not going to tell people how to live their lives, but it's your soul. If you want to bet on remote odds that there's no creator, that's up to you. And Matt says, Sal, you are absolutely correct. Can you imagine someone being taken seriously on suggesting Stonehenge formation happened by chance? And we are talking something so much more complex. Exactly. Now I've gone through all of this rigor to kind of like, okay, I'll tell you why, you know, maybe why I'm saying this. This is my way of saying, guys, you're not going to BS me anymore. All right. I mean, really, if I went through a year and a half of this, I got kind of sick of it. I said, okay, I'm going to lay down the hammer. We're going to do this textbook way. And you're going to try to challenge every step right here. And try to challenge it like you would in a university setting when you're teaching students statistical mechanics or statistics, probability theory. Are you going to dispute anything that I'm saying here? Because you're going to have to dispute textbook science. And that's what I'm laying down right now. I said, guys, I'm fed up with your BS. And I saw some BS being thrown out by Icarus. And I'm not trying to take it out on him. He might be just repeating talking points he heard from the people that generate lots of BS. And so I hope that he's been enlightened now. If he's watching this video, I really want to thank you for your comment. But if you're repeating talking points that someone fed you, that's garbage. I've tried to point it out here. So now Flash Gordon says, but we know mathematically, the longer the event for something to occur, the more it will average balance itself back into the microvariation states. If only determining factor is blind chance, random mutations, and random chemical reactions. All right, so now what this theorem is saying is, okay, you could see how improbable it is with 500 coins. The the homochirality needed in the cell is probably on the order of billions. So instead of 500 coins, we're talking billions of coins. All right, billions. The reason that your proteins have to be homochiral is they won't have the right biophysical properties. They won't be able to fold properly. You won't be able to replicate the fold if when your genome is trying to make a protein and the chirality is off, you're going to just destroy the alpha helices and beta sheets. And I was surprised. I was debating atheists. I said, oh, you didn't account for that, because they were just theorizing, just kind of off the cuff, like they often do, that you could build stable protein systems in cells using heterochiral, or basically 50% heads, 50% tails kinds of proteins. I said, you're not going to do it. You'll have a mess. The creature will be dead because the proteins won't function. So the law of large numbers is really, it has to be violated for us to live. For us to live, the law of large numbers has to be violated numerous times on numerous levels, at amino acids, at DNAs, probably for carbohydrates. And we also, I don't know that it's life important, but there's also chirality in the phospholipids in our membranes. There are so many levels where the law of large numbers is violated by cells. I mean, how much more evident design is there? They'll say, well, okay, I understand where people said, well, I haven't seen God, therefore I don't accept there's a miraculous explanation. And that's where some people are. Okay, but that's not me. At some point, something violates expectations so much, to me, it fulfills my definition of a miracle. So that's a little bit of statistical mechanics. I can go on just a little bit more.
Only
Lena, yes.
Flash Gordon has asked if he got it right. Yes, I think what he has written is accurate and correct. Yeah.
Yes, and let me now remember the point I was trying to make. If you have instead of 500 coins, you have 1 billion coins. 1 billion coins. If we have a deviation from the mean of 50% heads, it's not going to last long. The more trials you have, the more. So if you have a deviation, it's going to revert back to close to 50%. And this is what they call, yes, it's going to revert. It's not going to last long. And that's the thing that people said, oh, we have clay catalysis and we can create these amino acids that are homochiral. Well, in a high temperature environment like that homochirality won't last long. It's like taking a table full of coins that are all heads, and you have a kid just take one coin and just flip it. The more time he spends flipping each of the coins, it's going to approach 50% heads. And just imagine that with 1 billion. So even if you have a deviation where just by extreme chance you have some deviation from 50% heads, it won't last long. And that'll happen in the chemical environment. And the more coins you have, or let's say the more molecules you have, the smaller the percentage deviation is. The smaller the percent deviation from the 50% mean. So let me show this table again here. So you could see we can allow a little deviation. There's a chance we could have like a 0.2% deviation here, and it's possible. But the more coins you have, these deviations start to become really, really small. It just starts to get ridiculous to even get even 1% deviation from the mean, the more that you have. And so the idea, I think Flash was talking about, if you have more repetitions over time, what is the tendency? It's going to devolve toward the mean. It's going to devolve toward the mean. Or you could say evolve. Okay, it's just a choice of words, but we know numerically where it's going to head. And there was one thing I wanted to say, because this relates to thermodynamics. And let me see, I had a beautiful, oh yes, hyperphysics. And I'm going to share the let's see. It's kind of really too bad I don't have the link here. Let me see if I can recover the link. Okay, so I'm going to put this in the chat. You can study this, and you can see my fascination with casino math, because statistical mechanics uses a lot of casino type math and also to teach it. So if you're rolling dice, and this is from a casino game, but you could see it's a great way to teach statistical mechanics. There's only one way you can get 12 when you roll the two dice, where you get the sum of the two dice equals 12. And there's only one way you can get 12, only one way you can get 2. But there are 3 ways. Okay, so there are 2 ways to get the number 3 with the 2 dice rolls. I don't like the way they did this diagram. If they had some crayons to color it so you could actually arrange it. So you see that, again, there are 2 microstates that fulfill the macro state of being the sum being 3. And then there are 1, 2, 3, 4, 5, 6. There's 6 ways to get 7 out of 2 dice. So there's 6 microstates that have the macro state of 7. So again, I'm teaching just a little bit. This is for another talk on statistical mechanics and thermodynamics. And what we say is that the macro state has a multiplicity of 6, or the macro state has a multiplicity of 1. Thermodynamics says the system tends to go to the macro state with the highest multiplicity. And so when I was showing that the tendency is for a system of 500 coins to go toward 50%, this one has the highest multiplicity. Okay, it has the highest number of microstates for that macro state. It will tend to that. This is, again, echoing thermodynamics and expected values. And I'm sorry that this would actually be like a week of university lecture, and I've just blasted through it. And but I have a feeling some of you got a little bit more enlightened, I hope. And if you have questions, we can go into this in far more detail. I have a YouTube channel that I'm creating, which is Evidence and Reasons Academy, where we'll actually go through this in more of a university fashion and laboriously go through this so that people can get a more solid grasp of what I'm talking about. So it's been kind of my presentation has been kind of clumsy because I'm really, guys, what you've learned is graduate level, the beginning of like senior level, early graduate level statistical mechanics and statistics. All right. So this is not for the faint of heart, but I hope you can see that I'm trying to lay out, stake my claim, and said to my critics, I said, if you want to argue with me, I'm not going to take any more BS. You're going to have to argue statistics. And I really mean it this time. I really mean it, because I'm just tired of all the garbage that they're spewing, the illogic, the irrationality, the unscientific concepts. I said, I'm going to force you guys, if you're going to criticize me, you're going to have to deal with these statistics, because you guys are not telling the truth. You're dodging these issues, just like Nick Matsky dodged that simple question about 500 fair coins being all heads on the table. He dodged, tried to change the subject. I said, I don't know what's up with you guys, that you just don't want to deal with simple facts and theory that come out of textbooks. So anyway,
Yeah.
Go on, Lena.
No, I know Nick Matsky. I didn't know him from the Dover case, but I have seen his name in this website Evolution News or Evolutionary News. And as soon as you ask him a question, he will give you a link to this Evolution 101 site or some website with a lot of fossils and skulls, and he will tell you to find the answer there on that website. And he would imply that you are in basics ignorant, And you have stated that question because you have no idea whatsoever about evolution. So learn the basics. This is his answer always when you state a question. This is my impression, or my first impression of Nick Matzke, and I had no idea that he teaches students. I would say he is not the brightest star in the sky, if I could formulate it like that. You know what I mean? You are muted, so.
Oh, thank you. What would I do without you guys, huh? What would I do without you, Lena? I could have given this whole talk being muted if you didn't say something. So these are smart guys, but they're trying to defend a stupid theory. That's what ends up happening. If you're a smart guy and you're just defending a wrong theory, you're just going to look stupid.
Yeah,
And
he looks stupid. Okay, okay. He one gets the impression that that guy is not very bright, really. When you see what he writes in these forums and so on and so on. But maybe you are right. He is clever, but he sounds stupid because he cannot defend his position.
yeah, I mean, we may have a bright guy just for kicks trying to defend flat Earth, and he's going to just sound stupid because the facts don't agree with him. Not that I'm not into that. Okay, there's some people that want to practice their lawyerly skills and they'll defend something they know is false, and they'll try to come across, like they're making their case and they know they don't have a case, and so some of these evolutionary biologists, maybe in their heart they feel that they need to defend it, but then the facts aren't on their side, so they end up sounding stupid. And that's Nick. He's smart enough. He's kind of a slippery character, dodges questions. One thing I'll point out is I like to say, let's just assume for the sake of argument the fossil record, and people know I'm a young Earth creationist, that there is universal common ancestry. It still doesn't mean that it happened naturally. We can make these molecular arguments, and this is, Michael Behe nominally accepts universal common ancestry, but he still recognizes there has to be miracles along the way. He will say intelligent design. He doesn't use the word miracles. He will still point out there are things that are just statistically improbable that don't agree with his understanding of biochemistry. And so where we creationists, I think, are going to win the argument is not arguing about the fossil sequences. It's arguing the chemistry. We can win the abiogenesis debate handily. And I think we're on the edge of just destroying the eukaryotic evolution claim. There are other things that Change Tan discovered with orphan genes that will also destroy universal common ancestry for prokaryotes. And I'm going to have some journal club talks on that. So this is going to be really technical, but where I'm trying to distinguish this channel from others is the reason I'm being very methodical and thorough is I'm tired of getting BS'd. I said, okay, we're going to lay it out here, and it's not going to be a short debate, and they're going to have to fight me every inch on just textbook science. I'm going to just lay out textbook science, and let's say, okay, now we have a real fight here because I'm just going to pull stuff straight from the textbooks, and you're going to have to justify evolutionary theory based on accepted physics and chemistry, and you're going to fail. So, Matt, do you want to come on board and share a video? Matt, are you there? He wanted to share a 1-minute video. I think he left. All right. Well, maybe next time. Let me just scan the chat, see if I can't read all the comments, but let me see. Flash Gordon said it's not clumsy, it's intense, and I only have high school level maths, and worse because I'm in England and we don't have high school here. We have college. I didn't do maths at college. Okay, thank you. Matt and I said, okay, but the link isn't to the stream. Matt, will maybe another time. Flash Gordon says, but I did play snooker and darts and gamble on sports several years ago. Daniel says, Lena cracks me up. And shalom. I'm just looking to see if there's anything. Anyway, we put the StreamYard if anyone wants to. Well, we'll have another session. Lena, do you have any final thoughts before I close the stream? Oh, Matt's here. Session. Lena, do you have an? Oop.
Oh, hey, sorry.
It's all right.
Yeah, I didn't get the link to the stream. I was trying to join earlier, but yeah, let's see here. It's just a 1 minute clip. It looks like there was a delay from the YouTube stream and your StreamYard stream. So
there is.
Okay.
Okay. Do you know how to do you know how to share your screen and share your video?
Yeah, I'm working on that now. Okay. Okay, here we go.
What I want you to do is imagine a town called Lotto Town. 10,000 people in this town. Every day they have a lottery, and everybody in this town gets a ticket. Imagine on day one, a certain person wins the lottery. Imagine on day two, same person wins the lottery. Imagine on day three, the same person wins the lottery. At this point, the atheist says, I'd say something's up. Something's been rigged. I said, oh, you're a riggist. But when the sun comes up every day, you're an a-riggist. You think it just happens that way. How come in the lottery example, you're a riggist, but in the world, you're an a-riggist? You don't believe in God who's controlling the universe. See, in order to do science, you're borrowing from the Christian worldview. Because you can't even do science unless you start with God. For the earth is the Lord's and the fullness thereof. Who owns science? Who owns logic? Who owns morality? Jesus Christ. We don't give them to the unbelievers so they can argue against our worldview. Well, let's get back.
So that's just a short clip from it's a presuppositional movie, a short film, I guess you could call it. Well, it's an hour and a half long. It's called How to Answer the Fool. I highly recommend it to any Christian. But that's all I had to share. I won't take any more of your time.
Sorry. Well, thank you very much. And I hope we have more talks. And I'm just going to briefly check my, I won't check my email while I'm on air. The reason I wanted to check it is I'm hearing from James Coons. He's trying to get me to debate someone on Modern Day Debate in about. He's trying to get me to. Go on, Matt.
Oh, sorry. I forgot to take my mic off.
Oh, James wants me to debate someone like at the beginning of the year, so this could be exciting, and so I'm looking forward to it because I'll actually be arguing probability theory and casino math. So, Lena, did you have any closing thoughts? And before I end the stream, I'd like to wish everyone a Merry Christmas.
I just wanted to say, so go for that debate. You are getting better and better. And with more practice, you will get better and better. Oh. I'm looking forward to that debate at the beginning of the year.
Thank you. So it's not confirmed yet, so I'm not going to name names. Hopefully it'll take place within the next 2 weeks, and it's a chance for me to advertise this website. I really want to thank everyone who's joined this stream. It's highly technical. This is going to be the nature of the website for the technical stuff. And there are parts that are so technical that I started another channel just to get into it even in more detail to be able to give the topics justice. I will be having a little bit more of Christian testimonies. I hope those who joined us yesterday enjoyed the testimony of Richard Lumsden and Marcia Montenegro, and then also the Apollo 8 Christmas Eve message when they orbited the moon, which was tremendous. I think I think one of the best evidences at a personal level that the Christian faith is real is what Jesus has done in people's lives. Oh, and Matt, I wanted to thank you for sharing your testimony last night. And so with that, God bless you and Merry Christmas to all. Thank you so much for being a part of the stream, both to Lena and Matt, and then all the people that have joined us in the chat. So God bless you and Merry Christmas.
God bless all.